Hi, my name is Kevin Mairena, and this is Lab 4 Oscillations. In this lab, we analyze the motion of a spring swinging in an arc. We examine its motion using Newton's second law and the energy principle so that we may construct a model that can accurately predict the spring's movement. Here, we observe the phenomenon and notice that the spring not only moves in the y direction, but also moves in the x direction, acting as a pendulum. We have some initial conditions. The mass in our system has a mass of 0.402 kilograms. Our initial position from the point at which was released was 0.123 meters, and the position data that we update through the lab is obtained from the CSV file of the positions taken from tracker. Before we begin observing the physics, we have some unknowns that need to be calculated. To find our spring constant for the system, we use the period formula for the spring, which is T equals 2 pi root m over k. Since we can find the average period in our tracker, we use that in order to solve for k and use that in our equations as our spring constant. Besides the spring constant, we also don't know the full length of stretch of the pendulum. So we set F net equal to 0 and have the stretch of the spring equal the weight force divided by the spring constant plus the original position at which the spring began. Similar to our previous lab, the model updates the position of the pendulum and uses the time step to update the velocity and mimic the motion of the spring mass system. F net is calculated by the forces of gravity and the spring force that are present. So now we run our code, and we see that the model accurately predicts the motion of the experiment. In the graph on the right, we observe the motion of delta k, the oscillation of the change in kinetic energy, the change in gravitational potential energy, and the change in the spring gravitational energy, or spring potential energy. We also notice that the yellow line staying constant is our change in energy. Now our change in energy is essentially 0, which shows that it is a little bit off due to some uncalculable errors such as round issues in tracker. So now some follow-up questions. What does it mean? Our experiment, or our model, does satisfy the energy principle in that the change in energy is essentially equal to 0, which we can analyze, which we analyzed in our graph. For our what-if question, we are asked to compare our y and our periods in the y and the x direction. To do this, we found the average of a period in both our y and our x position data, and we notice that they're off. For this reason, in the y direction, even though it almost completely mimics the movement of a spring, some of the motion of the pendulum is involved in this direction. This also occurs in the x direction, where in the x direction, it doesn't just move like a pendulum, because the spring motion also causes the period to change.